Okay, we're going to go on to number 13, and we have the function 12x to the 2/3 minus 4x. We're trying to find out on what intervals it's increasing, and we know that f of x increases when f prime of x is greater than 0. So we need to find the first derivative and find out where it is going to be greater than 0. Okay, so we'll find the first derivative, and it is 2/3 times 12 times x to the negative 1/3 minus 4. And that is 8x to the negative 1/3 minus 4. Factoring out a 4, we get 4 times the quantity 2x to the negative 1/3 minus 1. We set that equal to 0, and that will be true whenever 2x to the negative 1/3 is equal to 1. If we made that into fractions and cross multiply, we get that will be true whenever x to the 1/3 is equal to 2, and that will happen whenever x is equal to 8. So the only 0 that we have there is x equals to 8, but we also have at x equals 0 that the derivative does not exist. So we have to test a sign chart having those two values on it, as they are both critical numbers of the first derivative. And I choose test values, negative 1, 1, and 27. I use 27 because that is the smallest cube uh, above above 8. Alright, so at x equals negative 1, x to the negative 1/3 is still going to be negative 1. 2 times negative 1 is negative, minus 1 is negative, so the first one will be negative. When x is equal to 1, x to the negative 1/3 is still 1. 2 times 1 is 2, minus 1 is positive. Next, we want when x is equal to 27, then x to the negative 1/3 will be 27, 1 over 27 to the 1 over the cube root of 27, which would be 1 over 3. 2 times 1 over 3 is 2/3 minus 1 is going to be negative. And so everything in that interval will be negative. So we're looking for where the function is increasing, and that will happen between x equals 0 and x equals 8. Okay, next we want to find out when the x and y coordinates of all relative maximum points. And a relative maximum will occur whenever the first derivative changes from positive to negative. That occurs at x equals 8. Now it asks for the x and y coordinates, so we plug into the original function because we're looking for the y value on the original function. X to the 8, when x is equal to 8, 8 to the 2/3 is the cube root of 8, which is 2, 2 squared, which is 4. We get 48 minus 32, which is 16. Part C, the relative minimum points occur when f prime of x from negative to positive. And that will happen when x is equal to 0. Plugging in x equals 0 into the original function, we'll get x equals 0, y equals 0. Next, we want to find out where the function is concave down, and we know that it's concave down when the second derivative is less than 0. So if the first derivative is 8x to the negative 1/3 minus 4, then the second derivative will be negative 8/3 x to the negative 2/3. Sorry, that's negative 8/3 x to the negative 4/3. And the important thing about it being 4/3 is that whether x is positive or negative, whatever we put into there will come out positive, and because the coefficient is negative 8/3, everything will be negative. So f prime prime of x will be negative for all x except where x is equal to 0. And we're ready at this point to use that information to construct a graph.